स्क्रीन मेरी विजिबल है क्या? अब आइए सर। ऑलराइट। Hi everyone. I hope I'm audible. Comment it if you can listen to me. Hi everyone. I hope I'm audible. Alright guys, I believe I am audible. So I welcome you all on behalf of IQ Path Technologies team, right? And I welcome you all in this webinar and the bootcamp, yeah, of AI and ML. So we'll get started with the idea of machine learning, what exactly it is, and we'll quickly move towards the hands-on, believing that you all have um, some knowledge about the Python, yeah. But don't worry, we'll talk about the machine learning basics if you don't know about it, yeah. And I hope language is okay, right? If you are okay with language, yeah. uh, I mean, मैं हिंदी में भी बात कर सकता हूँ, ऐसा कोई प्रॉब्लम नहीं है, right? But if you're okay with English, I will continue with that. All right. All right, guys. Let's get started here, right? What exactly is machine learning? Why we need to learn machine learning? Yeah. One thing that I would like to tell you before I start, right? Machine learning is an integral part of any of the data science operation. Think about Gen AI, think about agentic AI, think about deep learning, whatever you think about, right? Machine learning is there. So, I mean, the first floor that you create after Python is machine learning. Second floor is deep learning, and then the third floor is Gen AI, or maybe you can go for agentic AI. Yeah. Let's try to understand here what exactly is the scenario. So when I say the scenario, right, what am I trying to do is there's a company and who are really worried about the spams that they are collecting in their inboxes. All right. And what they want is they want a solution that can solve this issue. Yeah. What they want is they want a system which can detect the spam emails automatically and put them into the spam folders. Now earlier they have to go through the IT teams, and they have to send their emails, and then they segregate the emails into spam. And so this is scenario one, right? You can see what I can do is I can create a machine learning model which can get trained from the previous mails that I got, okay, and then we can expect a new mail comes into your inbox and can be segregated by that model into spam mails, or you can think about the um, the normal mails, right? There's another scenario, right? Why I'm telling you these scenarios, guys? Because these scenarios, or these problems I should say, can be solved using machine learning. All right. When you say this scenario is about e-cart. Okay. There's an e-cart company. I mean, there's a store, right? Online store, and they share they actually sell the apparels. Okay. And in couple of months they found that the sales is going down and down and down. So the point here is they are looking forward to use their historical data, the historical transactions of the data, okay, and then they want to utilize it to improve their sales. So can they do it? Yes, they can. So what is the solution, right? What is the solution? Okay, the solution is nothing but, let me just tell you about that, is machine learning. Yeah, let me just come to this point because I want to spend some time on hands-on. That's why I'm just saving some time, uh, with this. So if you just see that, how can I save my time, to set that filter, manually. So machine can help me. Or let's say I want to boost up my sales and the customer shopping experience. How can I do it? So machine learning is a solution for that. And you can see that every business want data-driven decisions, guys. Data-driven decisions. Very, very important term that I'm introducing. When you say data-driven decision, now they understand the importance of data. Yeah, they understand the importance of data, that how it can be utilized to enhance their internal operations, maybe the sales, yeah, maybe customer satisfaction. N number of different ideas can be done using that data. Okay, data driven decision is the key point here. Yeah, now let's try to understand what exactly is machine learning. Yeah, so uh, one thing that I would like to tell you before I move to this particular point, yeah, where this machine learning stands. So I think this particular diagram can clarify that where is that machine learning. So if you just see that artificial intelligence is a big umbrella. It's a big umbrella out there, right? Everything comes under this. So you might be knowing about the artificial intelligence. Basically, uh, when you want to mimic the human-like behavior from the machines, right? Then we call it as artificial intelligence. Okay. Inside that, we have machine learning. What we are trying to do, we are trying to train the machines. Yeah, machines in a sense here is a program, right? Don't think like a physical machine or something like this, right? It's a program. We train that program, that model. Yeah, I should say model is a specific word here. Okay, and then you're going to see inside that machine learning, the subset is deep learning, which is actually the backbone of Gen AI, agentic AI, whatever you think about. Yeah, RAGs and everything. So the point is you need to learn machine learning, and then you can go for deep learning. Uh, Basically, it is the hierarchy of learning. So can you see that machine learning is an important concept if you really want to work in AI, or you want to build your career in AI. Yeah, that is something that is very, very important. Let me just come back to the basic definition here. So if you just see here, the machine learning is a subset of artificial intelligence that I have told you, and you're going to see it permits the system to learn and improve. There are 2 points here: learn and improve. So they keep on improving, right? For an example, if I tell you that right now on Netflix I am watching horror movies, and after 1 week I decided to watch comedy movies. So this change should be adopted by the machines, and then it can recommend something. So in the recommendation system, there is machine learning behind the scene. Yeah, when we progress, you will understand all these things. Okay, so you're going to see that we have a system, right, to learn and improve from the experience, right, without being explicitly programmed automatically. Very, very important. Explicitly program. What does it mean? We're not doing something like if this, then that. If this, then that. No, we're not doing this. We are trying to understand the hidden patterns of the data and trying to train the machine learning algorithm, right? You can just see we talk about the algorithms in ML, right? That is machine learning, guys. Okay, and you can just see here the machines are getting trained by the data, that is historical data, and sometimes we also call it as a trained data. Okay, and you will see, after training this machine learning model, we try to evaluate the solution, right, in terms of the trained model, and then if everything is good, then we launch it. Otherwise, we analyze the error and try to rectify it. It is continuous process, guys. Right? It is never-ending process, right? We keep on collecting new data. We pass it to the ML models, and then new things come in, and then you can talk about the things. I hope you're getting the basic idea here. Okay. So you can just see that the scenario that I've told you, what a machine can do is machine can be trained with all the earlier, right, historical mails that we got, right? We already got the separated spams and the normal emails, right? So what a machine can understand by the historical data that we are feeding to the machines, right? You're going to see that historical data that we are trying to feed here, and then you can just talk about the inbox and the spams. The machine now will understand, right, which particular email should be labeled as inbox mail or a spam mail. That's a very common problem, guys, right? I mean, there are a lot of solutions ML can actually solve. All right. Okay. Now, let me just come to the idea of artificial intelligence. You might be knowing about it, but let me just quickly touch upon those things, and then we'll quickly move towards the hands-on. Because I know that you people might be waiting for the hands-on, right? How things are working, right? So let me just give you the things very quickly. Okay, and then we'll move towards the hands-on. Yeah, you might be waiting for that. So if you just see, when you say artificial intelligence, as I said, that it's a branch of computer science which emphasizes on creation of intelligent systems or machines, right, that exactly work like humans. That is artificial intelligence. Makes sense. Let's say, think about a smart home which manages its energy consumption, the bills, expenses, by its own. Yeah, so that's artificial intelligence, right? That we talked about the machine learning. Yeah, that comes next here to the artificial intelligence. You're going to see a subset of AI which gives a machine the ability to learn without being explicitly programmed. Okay, there are a lot of ways we use machine learning around us, right? We don't know actually. Yeah, think about the recommender systems. Think about the Google Translator, right? Think about a lot of things in social media, right? We use it a lot, but we don't know it. That is something behind the scene. Okay. Now you can see we talk about the deep learning. Yeah, we can talk about the deep learning, but the idea is like deep learning is subset of machine learning, in which we work with the artificial neural networks, artificial neurons, right? What we have in our brains, right? We have neurons, but what I want is I want to mimic the same behavior of the human brain from the machines. So I have to use artificial neurons, guys. Okay, that is something that I can use. All right. Now, moving ahead with this, right? I tell you a couple of very interesting use cases of machine learning. Yeah, you can think about Google. Yeah, I mean Google Maps. I'm talking about, right? How accurately it can predict the traffic and give you the best path out of it. Get it? That's very interesting uh, machine learning thing. Think about Amazon, right? It sells you a lot of products. Then how it recommends you the right product at the right time and to the right people. I think that's a very interesting use case of machine learning. It's all machine learning which is happening, right? It try to understand the human or users or customers' behavior, the choices, the interest, and give you the product as a recommendation, which is or which may you like getting it or not, right? A very very interesting use case of machine learning. Think about Alexa. Yeah, Alexa is also, I mean, that's a assistant, right? Virtual assistant that we have around us. that again keep the machine learning inside, and they try to understand the things and the responses. Every time it is governed by machine learning models that are there. Lot of such examples. You can just see machine translation using Google Translate kind of applications. Got it? I'm sorry. Yeah. Now we are heading towards the types of machine learning, guys. Right? So we have different type of machine learning. Although theoretically or um, I mean according to literature there are a lot of different types. But majorly we think about these categories. Like first thing we think about the supervised machine learning. Yeah, there is the input, which is nothing but along with the outputs, that is supervised machine learning. Or we can talk about the label data here. I'll give you some examples so that you can understand. Right, majorly the problems are supervised here in machine learning or maybe deep learning, right? Then we can also talk about the unsupervised machine learning problems. Okay, unsupervised machine learning problems are actually we deal with the unlabeled data. We talk about what is labeled, what is unlabeled, everything. Why? And there is another category which is reinforcement learning. Although there are very less use cases of reinforcement learning, but it's evolving day by day. Yeah, we have got Q learning and a couple of things like agentic AI. Agentic AI somehow uses reinforcement learning as well. Yeah, so we can think about it in the future. Okay. All right. Let me just give you a brief about the supervised machine learning, guys. If it is going a little faster, then please let me know if you want me to slow down. Okay. What I want is I want to show you, more hands-on, so that you can see something happening. Okay. Now you can just see I'm talking about the supervised learning here. So the diagram I think clarifies everything. The center part of the diagram, this one is a model. Yeah, you can see this is your input raw data, and the data that you are providing to it, yeah, is already labeled. So we know that it is an apple, it is an apple, it is an apple, right? If we have other fruits, then they are also labeled. And what we are expecting is we are expecting from this model, right? We can call it model as a whole, right? Although there are a couple of things like algorithms, right? Pre-processing, right? Training and testing, right? And then what we are expecting from this model, if we come up with unknown inputs, right? You can see this is unknown input. The model should be able to recognize the label. That's basically a classification problem, guys. इस problem को हम क्या कहते हैं? Classification problem. ठीक है, हम बोलते हैं इसको क्लासिफिकेशन प्रॉब्लम. हम समझेंगे इसको भी कि क्या होता है, राइट? हमारी धीरे धीरे आगे बढ़ते हैं. ऑलराइट, ये सुपरवाइज मशीन लर्निंग क्यों बोल रहे हैं हम? बिकॉज आप इसको देखो, वी हैव द इनपुट्स, एंड ऑल्सो we have the outputs. What we are expecting? We are expecting this label to be predicted, right? This is nothing but the label which we are expecting. All right. So if you just see here, this particular label is expected by the model. So what we are providing inputs along with the outputs. So whenever you think about the supervised machine learning, is always label data that we provide, and labels are nothing but the expected outcomes or expected outputs. Got it? So this is something that we have. Okay. Although in our whole course we go a little more deeper into this supervised machine learning and unsupervised. There's an example of supervised machine learning. Let's say we have raw emails, right? We got a lot of emails, and what we want to do is we want to segregate them into the categories like technology emails, sports email, or maybe fashion emails. Or also you can think about the documents, right? Simply documents can be categorized into these three based on the historical learning. That is something that you should understand. Historical learning, ये सब कैसे हो रहा है? जो हिस्टोरिकल डेटा है हमारे पास, उससे ट्रेनिंग मिली है मॉडल को, और मॉडल हमें प्रिडिक्ट करके बता रहा है कि कौन सा डॉक्यूमेंट किस पर्टिकुलर कैटेगरी को बिलोंग करता है. Alright, this is something that we have. Okay. This is good example of supervised machine learning. There are a lot of such examples, right? Okay. Now let's also talk about the unsupervised machine learning. When we say unsupervised, now there is no outputs. So the machine learning model is not fitted with the outputs that we have. So it is not a pair. We just only provide the inputs, not the outputs. Okay, and that is called as unlabeled data. It's called as unlabeled data. If you just see the input raw data in this illustration is unlabeled. We don't know what is this, right? We know, I mean, we can see that it's a banana, but it's not labeled. The model will not know that it's a banana. Yeah. Now what we are expecting from model, right? This is internal model that we have, right? Of course, it has got interpretation, algorithm, pre-processing. We have to go deeper into this. But if you just think about this output, yeah, so the output is clusters here, the groups of similar type of items that we are given as an input. That's called as clusters here, guys. Okay, that's called as clusters. You're going to see similar like fruits, right, which is red in color and similar in shape, right, is categorized here. Yeah, there is another fruit that is categorized here, which is yellow in color. There is another one that is mango. So we don't know even that is mango, right? It's just trying to understand the characteristics of the data that we are given, and then we can see this kind of clusters. This is also another very important use case, guys, of machine learning. It's called as unsupervised machine learning. Got it? Now, I want to give you an example of unsupervised machine learning. I think this is a very popular one, right? So when you think about the Netflix, right? Netflix suggests you some movies or some web series like this, right? You're gonna see. So what is this? This is nothing but the cluster of similar movies based on my choices, based on my earlier subscriptions or earlier interactions, right? It is just suggesting some movies. So what is this? It's nothing but a cluster of movies which I might be interested in. I getting this. So this is unsupervised machine learning because we don't know, yeah, or the system don't know actually what movies I will like. Get it? So this is something that we have as an example of unsupervised machine learning. Now, I don't want to move ahead from this particular point and want to show you that what is the flow of machine learning, what we do actually in machine learning before we train the machines or we get the outputs. Yeah. So let's do one thing. Let's move to the ink now. That would be a good idea to use, right? So whenever you think about the ML workflow, right? ML workflow. What does it mean? What are the steps that you follow, to do that machine learning? Okay. So let's try and understand what is the ML workflow, and then we will be targeting the pre-processing part, guys. Okay. So what we have is we have raw data. We have raw data, maybe a data set or maybe coming from any other source, right? Then what we do, we try to split that data into two parts. We have train subset, yeah, train subset. So basically the data, right, or a subset of data set, yeah, which we'll be using for training. Okay, and then we have test subset. What we have? Test subset, right? Now you can see here, of course there will be more data in training subset. Like for example, I have 70% of the data in train part and only 30% of the data in the test part of it. Got it? What is the next step, right? The next step, we will train our algorithm using the data that I have in a train set. So I'll have an algorithm. I'll choose the algorithm here, yeah, based on the requirement, whether we are solving regression problem or classification or some other, no problem. So what we are doing here, we are actually doing training, right? You can see training, okay, and in machine learning lingo it is called as fitting. Okay, don't get confused. If we say fitting an algorithm, that's also good, no problem. Okay, And after this, what we try to do, we try to get a model. It is called as trained model. You can see that trained model, trained model. The model which is already been trained with the train part of it or historical data. Now what we try to do here, we get our test data, okay, because we got the model, right? Now we get the test data from here and we pass it to the uh, model. Yeah, what is the purpose here, right? Purpose is we want to know that how good is the model on the test data, which is unknown data basically, right? We have not used this test data still, right? So basically this is nothing but evaluation that we are trying to perform. See, whenever we train machine learning model, we try to evaluate, right, how good the fitting happened, right? Okay, so this is something that we are going to have, right? And this is testing, what we call it as. Just a second. This is testing that we are trying to perform. Testing. Okay. And then we get the performance out of this evaluation. Okay. We get some predictions. Prediction. Okay. This is a prediction. And if the predictions are up to the mark, right, we can also calculate the accuracy on the top of it, right? We can understand what is the accuracy of the model. Let's say if the accuracy of the model is good, we can directly deploy the model. Or if it is not up to the mark, right, what we can do is we can go back and train the model once again with more and more data. But that's how it works, right? You can see we got some train data, we got some test data, then we do something. One thing is very important that we have missed here, that is called as data pre-processing. Okay, so I want to tell you that before I pass the data into the machine learning model, this particular aspect, right, training or fitting, here in this part, right, we pre-process and analyze, right, analyze the data. We try to analyze the data at this point before we pass it to the algorithm. We need to understand that what kind of data the algorithm can actually accept. Yeah, whether it is numerical data, whether it is categorical data, right? A lot of things we can actually understand. So it's a pre-processing that is very, very important. And analysis. Sometimes, analysis is called as EDA, exploratory data analysis, and that is what is the focus today. Yeah, I want to show you that how we perform EDA. हम EDA कैसे करते हैं, right? ये बहुत ही important part है, right? तो थोड़ा सा इसको और समझते हैं कि इस ओवरऑल प्रोसेस को मैं बोलता हूँ डेटा प्री प्रोसेसिंग. Data pre-processing. When you say data pre-processing, there are a lot of aspects that we see. Okay. First, we talk about data cleaning. So what we do is we try to remove the inconsistencies from the data, right? In terms of maybe null values, right? Null values हो सकते हैं हमारे data set में, maybe duplicate values हो सकती हैं, duplicates हो सकते हैं, wrong formats हो सकते हैं, wrong format of the data, right? Then second thing that we have to do is transformation. I hope you can see it, right? Transformation. We sometimes need to change the form of the data which the algorithm can actually accept. Got it? So transformation is needed. Yeah. Type conversion. Then the third thing that we do is EDA, exploratory data analysis. Why? What I call it? Yeah. Let me just tell you. It's funny, right? You might heard about the term KYC, know your customer. Yeah. I call it know your data, KYD. So before use it anywhere, like maybe in machine learning algorithms, maybe 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 in deep learning, anywhere, right? You have to do this EDA. That is called as KYD, know your data. So you should know your data before you actually use it. Got it? That's called as EDA, exploratory data analysis. And there are a couple of steps that we have to perform here in EDA. Now, while knowing the data, while knowing the details of the data, we perform a couple of things, right? First, we make use of statistics, right? That's an important pillar of data science. Stats, right? We try to understand the distribution, try to understand the skewness, mean, median, mod, like central tendencies of the data, right? We use the stats in EDA. Or you can call it as statistical description of the data. Or statistical analysis, you can call it, no problem, right? Whatever you feel like good. Okay. There are a lot of things you can think about: the distribution, how distributed is the data, where is the mean, where there is an outliers or not. Yeah, there are a lot of things we can actually get from this type of analysis stats, right? Secondly, we do univariate, univariate, bivariate, and multivariate analysis. What is this? You know, let me just tell you. When you say univariate, no, we try to analyze one variable at a time. What is a variable, right? So when when you talk about the structured data, right, there are always columns that we have, right? Think about the details of a car. So it can be manufacturer, it can be model, right? It can be engine capacity, it can be fuel types. These are all features, or we can also call them variables. There are different lingo that people use, right? So these are variables, guys. These are variables. So when we take one variable at a time to analyze, right, then it is called as univariate analysis. Yeah, it's all using visualization. I'll tell you that. When you say bivariate, then we try to establish the relationship between x and y. Yeah, like there are two features, x and y. Okay, let me just give you a real time example rather. Let's say I want to understand by the experience of the employee, when the experience is increasing, right, how the salary of a person is increasing. Yeah, is it something like this? Yeah, or this is the data, right, that we have, right? Makes sense. So this is bivariate analysis, right? We do this bivariate analysis here in this type of things. We can also do multivariate analysis. I mean, we try to understand the impact of the all variable in the entire data set. Okay, multivariate. You might be interested in how do we do it, right? So basically, we actually draw multiple graphs. I'll show you that, and charts. Right, like univariate, I can draw simple box plot or simple scatter plot, right? Can be done in the bivariate. You can think about correlation analysis in this multivariate analysis, right? There are a lot of good stuff here, but by doing this you can know about your data. KYD. Interested in this, right? I hope you got an interest in this particular part, that is EDA, right? How it is done, what to do in all these things, right? Like univariate analysis, bivariate, multivariate. Yeah, we'll be doing all those things today. Don't worry, I'll be showing you in a hands-on. And then after we have done the pre-processing carefully, yeah, then only we have to pass the data into the machine learning model. Although there are a couple of more things in the pre-processing. Yeah, let me just draw it here. Yeah, I don't have space here, right? So we also do scaling. Yeah, we can also do encoding. All right, you might be getting that idea that pre-processing is a very important step. Trust me, guys. when you do data science or machine learning projects or deep learning projects, no, 80% or I mean more than 70%, I should say, time you spend on machine learning, pre-processing, data pre-processing here. I mean, you prepare the data, for the machine learning model, and that's important. Why? Because when your data is processed, right? Like when you say the data is clean or pre-processed, data pre-processed. When you pass this clean data, this organized data, this encoded data into the model, then you can just see the model can give you accurate predictions that directly depends on accuracy of the model. Getting it? I hope you're getting this idea that if we do the pre-processing rigorously, the model can capture the relationships well, and then you got the accuracy. Now, guys, I want to tell you that what is my plan. Yeah. Today, right? Today, I'm gonna spend some time on EDA. Yeah, EDA. Let's perform the EDA in today's session. Yeah, and then if time permits, we can definitely go for model training and all. But if if we cannot do today, right? Tomorrow, yeah, tomorrow we can do the model training. That's a project basically, right? We have to do both the things, right? We have to do the both the things. So please join tomorrow as well, so that you can see this, because we have limited time, guys, right? We have only 1 hour. Yeah. So I mean, let's continue, right, with the EDA. Okay, and then if time permits, then we'll definitely have a look into the model training today. So are you guys ready to understand the EDA in the hands-on part? Let's also do the hands-on. Yeah, let's try and understand something inside this. Okay. One thing that I would like to tell you that I will be using Python. Yeah, and in Python I will be using those major libraries like NumPy. Okay, pandas. Pandas, right? Okay. Then we may use Matplotlib. These are most popular libraries, right? Matplot. We'll also use scikit-learn. In short, we call it sklearn. Scikit-learn here. These are all most popular libraries in this. Yeah. Okay. There's a question that I have, that are all models fundamentally same when created? No. No guys, no guys, right? So depending upon the strategy, like for an example, if we talk about the regression models, they follow the idea of regression and the calculation is entirely different. Okay. And then let's talk about the tree-based algorithms like decision tree, random forest, XGBoost. They follow a different approach, non-linear approach, right? When we go into the course, right, we go even more deeper into different types of algorithms that we have and what is the best fit, right? I mean, where to use which particular algorithm. Okay, so they're not same at all, right? Depending upon what type of problem you're dealing with, and then you choose the algorithm. Makes sense? I hope I answered your question. All right. So we'll be using all these libraries on a data set. Okay. So let's have a look, right? What we have. And what I'm going to do is I'm going to use Google Colab, right? I'm going to use Google Colab here. That's the interesting IDE, right? Although there are a lot of IDEs, right? But what I feel is Google Colab is very good, and it supports GPU kind of thing, right? Okay. All right. So let's go and see it in the hands-on. So let's open a new tab and let's follow the Google Colab. I hope you can see my screen, right? All right. So this is the Google Colab. I hope you might have heard about it. Don't worry. If you don't, that's very easy to use IDE, right? We just have to click on this new notebook, and a new blank notebook will be ready for us to work on. Now, just to make it simple, right? Let me just work with uh, the the simple loan kind of data, right? Where we have customers' information, like what type of loan they have opted for, what is the loan amount, right? Whether they repaid or not, right? Something like this. Okay. So I'll show you the part of it. So let me just name it IQ path IQ path demo. All right, IQ path demo here, and we'll get started. So I need data, right? I need data for that, and let me just bring the data for you so that I can show you that. Can I get a data from here? Okay. Okay, let's do one thing. Let's get it from Drive itself. Hmm. I quickly get the data for you. Yes. I didn't know that, otherwise I would have. I think there are some good data sets here. So let me just something. I think we have to search for it here. Let's search. Yeah, I think that's CSV that we can have. Yeah, probably that's a good one. Just wanted to confirm that that's the one that I wanted to work with. Okay, and it is there in the folder. I have to look into that first. I just forgot, where is that? Yes, I think here it is. Mhm. Got it. Let's go and let's download. Right. Whenever we work with the data, right, so we have to upload it here in this space provided by the Google Colab, right? So once you see this, right, yeah, I have to upload that data set that I have got, and quickly I'll be showing the data. Don't worry. So this is the space provided to you, right, where you upload your data, and you can just copy your path from here because I will be needing it. Okay. Now, once you're set, right, your data is ready. Okay. What you can do is, right, just a second, you can get started with your coding, and the very first thing that you do is import the libraries. Okay, import the libraries. So let's import the libraries, right? Import numpy as np. Okay, let's import pandas as pd. Okay, and from matplotlib, right, I'll import pyplot. That's the Python way of plotting everything as PLT, and I think that's enough. We can also import some other, but right now we need these many only. So let's run it, and now let's quickly head towards loading our dataset, right? So let's load dataset. Okay, let's load the dataset. How do you do it, right? It's very simple. You just have to create a data frame object, right? and call the function. Like from pandas, the function is read underscore CSV, and you can pass the entire path of the data. See, loans, content, and loans. That's the path of this storage. Okay, that's in online service, right? So you cannot actually access your local files from here. Okay, and once you're ready, right, you just have to call a function so that you can see the data set. Head function basically give you the top 5 rows of a data set. Okay, that's it. So can you just see the data? Yeah, you can see we have client ID. Yeah, we have loan type, right? Different type of loans like home loan, credit loan. These might be the client ID, right? Customer ID. So it is also possible that a person have opted for different loans. Okay, so just see loan amount, different loan amount, repaid or not. So whether repaid or not, right? This is something very important. Then this is loan ID, loan start date, loan end date, and the rate of interest. Okay, you might be interested in how many records we have, right? So you just see only top 5 records, right? So I'll start the exploration of the data by using a very simple function from pandas that's called as df.info function. That actually give you the details of the data frame. Yeah. So if you just see that if I run it, yeah, if I run it, give you the entire information about the data frame, like how many entries we have. We got 443 entries. That means we have historical data of 440. This is a small data set. I just take it as an example. Okay. And then you just see there are different columns. So how many columns? We have 8 columns. So it is horizontally small and vertically also small. No problem, right? So just keep it simple for you guys, right? So if you just see that we have data types also, very important input, right? What type of data we are dealing with? Yeah, we're dealing with the numerical data like integer 64. Sometimes it is object also. Can you see object? What is this object basically? Okay, the object is nothing but the non-numerical data. Okay, I got a question that what is CSV? Okay, so CSV is a file format, right? CSV is a file format. Basically, it is called as comma separated value file. It's a most common file format that we have when you do the data storage. Yeah, simple file in which the data is separated by comma, right? That is CSV. Okay, very common format. Okay, now let's do a couple of more exploration. Okay, so you can see that I'm going to start exploratory. Sorry, I should get it into the text, right? Yeah, so I will get started with exploratory data analysis. Okay, that is nothing but we call it as EDA, right? And I call it KYD, if you remember, right? That is nothing but know your data. So using this we can actually have an understanding of the data. Exploratory data analysis, and you can opt for any sequence here, no problem. Yeah, any sequence, but the main idea is like you should be doing statistical analysis, you should be doing the univariate bivariate analysis. Yeah, you should do it complete. Okay, all right, so let's get started with the data analysis, and the first thing that we do is descriptive way. Descriptive analysis. All right, and pandas is the library which can help you a lot doing all these type of analysis. Okay, and you're going to see df.describe. So df.describe is a function which give you the statistical summary of your data. Yeah, once you call df.describe, right? So once you hit it, right, you see something like client ID, loan amount, right? I should have opted for client ID, but we have included it. So can you see the average loan amount? You can see there are a lot of things that we have: count, mean, standard deviation, yeah, min, right? Like minimum value, 25th percentile, 50th percentile, 75th percentile, and then the maximum value. Okay. You just see some values here. Like for example, the rate of interest. Okay. The average rate of interest for all the loan is 3.21. Getting it or not, right? So mean value. You will also see the max value, right? The maximum rate of interest that I have for any of the loan is 12.62. Minimum is 0.01. Very low interest, right? Okay. We can also see the standard deviation of different data, right? You can see the standard deviation here. You could have actually done it separately, no problem. I mean, you can pick up any column and you can definitely calculate the mean, median, mod, everything separately. But I think describe function give you that summary of the data, in just one go. You just have to call the describe function and summary is in front of you. Yeah, that's a good thing actually. But one thing you should notice here, okay, you should notice when you see the the data, right? You only see the numerical columns. Yeah, you can see here we have couple of object type of column, like the loan type is object type. Yeah, non-numerical data. Yeah, you can see loan start, loan end, these are also object type, although this should this supposed to be the date and time, right? But these are objects. We can definitely convert them, no problem, right? Convert them into the appropriate data type. We'll be doing that soon. So we can see that the data types are giving trouble, right? You can see loan start, loan end. So we can do it. That's also a kind of pre-processing of the data. So in the pre-processing of data, let's do a type conversion. Yeah, convert features. I mean, we call them features. Let's use the standard terminologies, right? Convert features into appropriate data types. Let's try and do this. Okay. So if you just see that the loan ID that we see is numerical, no problem. Loan start is object. This should be date time, right? So let me just tell you how we can do it. It's very simple to convert. Again, pandas functions can help us. Okay. So what I can do is I can point out that particular column like this. Which particular column I want to convert to? The loan start, right? Because right now it is object. It is string. Whenever you see object, right? It's most probably string. We don't want strings, right? So what you can do is you can simply point out that column, yeah, and there's a function pd dot to underscore date time. Simple, yeah, and you can pass the column once again. So what I am doing is getting that column start, yeah, converting it into date and time and putting back to the data frame, right? That's something that I'm doing. Okay, very simple way of doing it. Sometimes, let's say if we are really very interested in format also, we can also do that format changes and all, right? So we can define that format, in which format you want that date and time to be. Yeah, like the format I have, or I should point it out like format. Okay, format. So you can define it like this, %d. So you want date, then a hyphen, then you want month, and then you want the year. Simple date and time format. Similarly, the loan end is also an object, right? Can you see this? One thing that I would like to tell you from my experience, that don't carry the object type of data before you do the machine learning training, because machine learning algorithms do not understand the object type data. They just hate it. Yeah. Okay. So after doing this, right, let's run it. Let's call that info function once again, just to verify that the conversion that we wanted happened or not. So if you just observe, now the loan start and loan end is date time. Can you see that earlier it was object? So as a part of pre-processing, we have also converted the columns into the appropriate data type. Okay. Now, let's continue our journey in the exploration of the data. Okay. Let's try and understand how much more we can do. Okay. The next thing in this process, right? Let's also look into the null values. Yeah. Check for null values. Just think about it. If a data set has got a lot of null values, okay, then do you think is it useful data? Because most of them are null. Null means the data is not present actually, right? So we need to check for the null values, right? That's very, very important. Null value or missing values. I mean, one are the same thing, okay? Missing values. But how do you do it? Yeah, basically, you again take help from the pandas function, and there's a simple function called as is null, and you can then followed by some function. Some function basically give you the total number of null values in your data. Right now, fortunately, we don't have null values. You can see this. Can you see that? It gives you the total number of null values in any of the column if there. So right now you can see client ID do not have any null value, loan type do not have any null value, loan amount do not have null value, right? So it's all zero. But as a part of process, we should see uh, the things here. Okay. So we don't have null values. That's fortunate enough. Otherwise, we would have to process those null values, right? We have to impute or we have to do something for that. Yeah. Now, let me also give you some univariate and bivariate analysis. We have done the statistical one, right? Now let's move towards the univariate analysis. I mean, in EDA, we are part of EDA only, but we are doing univariate analysis. Okay. So we can do a lot of things in univariate analysis. We can see, how the loan amount is distributed. Yeah, how the loan amount is distributed, and couple of things like that. So let's try and understand the very first thing, how the loan amount is distributed. Okay, we can also think about the loan type, right? So let me just show you the loan type. Let's pick up the loan type. Okay, so what I can do simply is df, and I talk about the loan type here, loan underscore type, right? Loan type, and I can uh, simply have dot plot function. There's a plot function, and the kind of plot that I want is a box plot. Or no, sorry, not box plot. Bar plot will be good. And just see the magic. Okay, I think the name of the column. Okay, it's not types. It is type. I'm sorry, my bad. Okay, numerical data to plot. Ah, got it. So we should be using the another type of element here, because the type loan type is categorical. Can you see that? So that will be difficult to show, right? So instead of it, right, let me just show you the loan amount, right? How it is distributed. Let's see the loan amount, and the type of graph that I want is histogram. Let's try and see this. Yes. Can you see this? This is the distribution of the data. Yeah. This is a kind of bimodal distribution, guys. Okay. We have to go very deep into the idea. Yeah. Okay. This is something that we have. Okay. Guys, there's an information for you. So plot function. Okay. There's a question, sir. Please. So Ranu asked me that, sir, please explain the plot function. Okay. So basically, plot function is again a function from pandas. So whenever we want to visualize anything, right, at a simpler level, right, we don't want any hi-fi fancy graphs and charts, right? Then we can use simple plot function plot function basically is on a column of a data frame, yeah, and then you can actually have the the type of the graph that you want, right? Sometime bar chart, sometime histogram, sometime box plot, yeah. These things can be done, yeah. I want to show you one more thing, right? We can also look for the box plot, right? Basically, that's nothing but outliers that can be understood, right? Whether there are outliers present or not. Okay, outlier, and what I can simply have is a box plot. You can see earlier I have histogram, right? You're gonna see the data which is there in the um, there in these ranges, right? You can see 0 to 2000, 2000 to 4000, 4000, 6000, like this. We can of course adjust these things, but we can also use this box plot. Can you just see that? This is very nice box plot. Although people don't understand what that box plot is trying to explain. Basically, it is trying to explain the IQR, interquartile range. Yeah. So basically, box plot is used for IQR and the outliers. Yeah. Very, very interesting graph, right? This middle line indicates the median. Yeah. These all whiskers, right? They're called as whiskers. They show the maximum and minimum. Okay. Okay. We have to go a bit more detailed understanding of this box plot. Yeah. Definitely. I wish I could have more time, so I can show you that. Hmm. So I hope you're getting this idea, right? If you remember the ing that we have discussed, right? In EDA, we do a lot of things like data cleaning, yeah, nulls, duplicates, wrong formats, right? We do transformation also, yeah. So instead of transformation, we jumped into this bivariate analysis and all, right? Uh, I want to show you one more, like bivariate. Let's see if we can do bivariate as well, right? Bivariate analysis actually coming up with multiple features. Like if I just give you an example, okay, like uh, on the basis of loan amount, or I should say the loan amount and rate, how they are related. I want to understand the relationship between loan amount and the rate. I can get something out of this, right? So what I can do is I can go for a simple scatter plot. Scatter plot. And how do I do it, right? Now I'm going to have the plot function. Yeah. Yeah, I'm not using matplotlib, guys, right? Matplotlib can be used here, no problem, right? But right now I'm just trying to use the simple plot function. So you can see that kind of scatter. On x-axis I want loan amount and the loan tenure. So tenure is not right. I think it is rate, right? So let me just mention the rate, right? You can see this. This is a simple scatter plot which tells us that the rate of interest is evenly distributed, and for higher amount of loan, can you see when you have higher amount of loan, that rate of interest is also a bit higher, right? So we do this kind of analysis on data to make it ready for the machine learning models, right? Okay. We can also see the correlation, that is multivariate analysis. That's a very simple example of bivariate analysis. Let me just mention that. Bivariate. So we can pick up two of the column and we can do the analysis. We can also do multivariate analysis. Let me just show you the heat map and a couple of more things. Of course, we have limited time, guys. We are not going very deep into these things, but when we do it, actually, yeah, we go very deep into that. Okay, okay, and let's say that you want to do the multivariate analysis, right? So correlation analysis is the most useful one. So what am I doing? Just see, I'm having core, that's nothing but the object here, df dot core. Okay, core is the function to do that correlation analysis. For correlation analysis. Okay, I got the core. I can show you this correlation just like printing core. Can you see this? I think that will not have the home. Yes, that's a problem with the core function. Yeah, we have to convert that home. Basically, we have those categorical columns also, right? We have not yet done something with that. Yeah, so no problem with that, right? Let's do another way. You can do it. Yeah. So I would like to say that include. Okay, or we can simply point out some numerical columns like this. I hope you can see it. Let's point out some numerical columns. Okay, like the loan amount. So I'm just trying to give you an idea that how it works, right? The loan amount, and once we have another, just looking at the name of the column that I can have. I can have repaid, yeah, and the rate. Let's pick up three of the columns. Okay, and the rate. Yeah, I think that should be done. Yes, we got the correlation matrix. That's called as correlation matrix. What I can do is I can show you this correlation matrix in a heat map also. Yeah, that is again a very good idea to do that, right? Heat map. Okay, and heat map is there in Seaborn, right? There's another popular library for Python. Yeah, so you can just see we have to import Seaborn. Yeah, let's import a Seaborn, right? Seaborn as SNS, and you just need to call that heat map with this correlation matrix that I got and annotation equal to true. You can see this. There's a correlation matrix, right? Although we don't see very high correlation in these features, but definitely in another data set we can definitely have it. This is a heat map, so we can read it like this, like it's a matrix. Rate and loan amount is negatively correlated. Yeah, you're going to see 0.016 negative correlation with the rate and repaid. Okay, so sometimes we found some strong correlations, right? Sometimes we may not. Got it? So you can just see that a bit of EDA, I hope you understood. Yeah. Although you can understand that we have limited time and we cannot go really very deep into this. Okay, but don't worry. In the next part of it, right? We'll do a machine learning, right? Or we'll train a model. Yeah, maybe a simple linear regression model we'll do here. Yeah, or we may also use any classification algorithm. We definitely continue with this part. Yeah, and then we'll see how we do it. Okay, so I hope you enjoyed the session, guys. I know this was fast-paced session, yeah, but we do all in a lot more details in the real courses. Yeah. So how's it? Let me just know in the comment section. Yeah, how do you like it? If you want to see this code, right? If you want to get this code, I will be sharing it in the description of the video, right? You can get it. Yeah. So thank you so much, guys. I just forgot to tell you my name, right? It was a quick session. My name is Ajitab, guys, right? I mean, there are a lot of comments. Please name your name, sir. So my name is Ajitab, guys, and I work for a couple of organizations like Yes Technologies, TCS US. I work for EduReka. I work for Great Learning, IQ Path, right? A lot of different assignments I have, right? Uh, okay. So that's me. Okay. I'll see you tomorrow, guys. I want to see you all tomorrow because tomorrow we'll have a very interesting session. Yeah. Okay. Let me just see if I can Yes, sir. All right, everyone. Thanks for joining. I'll see you tomorrow.